Hello and welcome to Software Architecture course. We will continue with design patterns. So in this lecture, we will study the structural design pattern. In this lecture, we will consider a set of design patterns that are important for structure. The last one in structural pattern is called the proxy pattern. We'll study proxy pattern. So let's understand the motivation and the intent of proxy pattern. Now the main motivation is that we require the ability to control the access to an object. We want a mechanism by which whenever we want, we can either restrict or open the access to an object at runtime. For instance, if we need to use only a few methods of some costly objects, we will initialize those objects when we need them entirely. So suppose there is an object that has got a lot of methods, and it's not very easy. It's easy as in terms of the amount of time it takes to create the object, the amount of memory that it consumes, the amount of CPU usage that is associated with that object is very high. So in that sense, it's a costly object. So if I just require only a few methods of that costly object, and for that purpose if I basically instantiate the entire object, then it becomes a waste of resource. So in that case, proxy may be useful to just get only those few methods, and for those few methods the proxy will ensure that such a costly instantiation is not required. Essentially, as long as we require only few methods, then the proxy can basically, as the name suggests, the proxy basically gives a proxy to the costly object and essentially expose only the light object, only the light methods. It does not really allow the users to access the heavy objects there. So these light objects are essentially proxies. So there is a heavy object, which is heavy. Costly means that it consumes a lot of CPU resource, a lot of memory resource, and these light objects are essentially acts as a proxy to this heavy object, which basically does not allow the client to interact directly with the heavy object. Essentially, some light methods, simple methods, are basically served by the proxy. However, when a client really requires those heavy duty methods, in that case proxy can instantiate the heavy objects, otherwise it does not. So this is the ability to control the access to an object. So when a costly object needs to be instantiated and initialized, how do you control this? How do you make sure that the costly objects needs to be instantiated and initialized only when it is required, otherwise it is not? Proxy pattern becomes quite handy in that situation. Essentially, what it does is it provides different access rights to an object, as well as it sometimes provides a very sophisticated means of accessing and referencing objects which are running in other processes or even in other machines. So in such a case, it provides quite a sophisticated means of accessing and referencing the objects. Let's look at a simple class diagram of this proxy pattern. Hopefully this will clarify the point of heavy and light objects. So in this particular class diagram, there is a server interface, and this server interface has a set of methods like do operation A, do operation B, and so on. And there is a real server which implements all these operations. And there is a proxy called server proxy. So that server proxy essentially has a reference to the server, real server, and it also implements those operations A, B, and so on. Now let's look at the methods in detail. So this particular interface, server interface, it's basically implemented by the real subject as well as a proxy. That's the first thing. The real subject is here, which is a real server, and proxy basically represents this real server. Proxy essentially, as I said, maintains a reference and selectively exposes this reference. It does not expose all the time. So because server proxy is essentially implementing the same interface, it provides these methods operation A, operation B, and so on. But let's look at this particular method carefully. Do operation A. So when the server proxy is created, essentially it instantiates a real server. It need not do it at the time of instantiation of server proxy. It can do it even later, depends on the situation. But important part is, let's look at operation A. So first of all, it checks if the client is really allowed to perform this operation. If so, then it actually makes a call, server reference dot do operation A. It basically calls that and then returns the result. However, if the client is not allowed, then it takes the appropriate action. So in this example, the server proxy is basically controlling the access of different methods of the real server. There could be other mechanisms as well, where it, instead of actually calling the real server, it can basically implement the operation at the proxy level itself. For example, in do operation B, it can do this. So essentially, not just control, but also it can it can allow or it can actually control the creation destruction of the real server. Here in this example, I have shown that it is creating this new real server. Now when it should be created, it's again, as I said earlier, it is completely situation dependent. It is not always the case that it has to create the real server when server proxy is created. It can create the real server much later, depending on the situation. So what does a client do? Client essentially obtains a reference to a proxy, and client essentially handles the proxy in the same way it handles a real subject. So client basically gets a handle to server interface and calls a method do operation A. So client is possibly not aware of the fact that it is interacting with the proxy. Client assumes that it is interacting with the server, and it calls the do operation A, and the server proxy takes a decision whether for this client, whether it should allow the client to actually make a call to real server, or it will block the request. So let's look at the code in detail. So this simple client has the main method. So it creates a server object, server refer interface, server equal to new server proxy. Then it sets it up, do operation A, do operation B. And then it can essentially execute this commands like so these two examples, like running commands ls minus ltr, rm minus rf, etc. These are all being done at the server end. Let's look at some more examples of this proxy. One is a remote proxy, Java RMI. Here an object on one machine executing in one JVM called the client So this particular client can invoke methods on a remote object on another machine, another JVM. So this proxy is also called a stub. It resides on the client machine, and the client invokes a proxy as if it is invoking the object itself. The proxy itself will handle the communication to the remote object and so on. So in this case, the purpose of the proxy is to hide the distributed nature of computation. Essentially, client is really not aware that server is in another machine. Proxy takes care of communication, interaction, and so on. So here the purpose of proxy is not to limit or restrict an access, but the purpose is to ensure that basically abstract out the location of the server with this, so that the client is really not dependent on where the server is. Now this proxy pattern we have already learned earlier in the architectural pattern discussion. So it was distributed systems in which there were concepts like stubs and skeletons, and so those stubs are essentially the proxy patterns. So this again highlights the fact that how architectural pattern can actually use design patterns. In this case, architectural pattern is using this more general purpose and more specific pattern, which is a proxy pattern. So the distributed architecture uses proxy pattern. In this case, in the Java RMI case, proxy basically contains the machine address, the process ID, and object ID. Let's see some more examples. Another example is called the virtual proxy. Virtual proxy is also called lazy loading. So when the data size is huge, then this proxy does not load the server immediately. It loads later on. So in that case, proxy really is a lightweight replacement of the complex or heavy object. It basically uses a skeleton representation. For example, when an underlying image is really huge in size, let's say the data is actually an image, it's huge, huge in size, then the virtual proxy object just represents a very lightweight version of it. On demand, it loads a real object. Another example is a protection proxy. It restricts an access. One example I have given in the class diagram itself. Depending on the client type, it can either allow or completely stop a particular method call. So in fact, it checks the access right of the client before invoking the actual operation. Examples of proxies that we see in real life are, for example, there are proxies that are there in corporate network. So it's really not a proxy design pattern as we are discussing here in the context of programming language, but the notion of proxy which is restricting access, the same philosophy that exists even in the corporate network settings, where there is a proxy server itself which is essentially controlling various access requests. For example, in a particular corporate, maybe the public emails like Yahoo email or Google email is not allowed. So any request to such email access will be filtered by the proxy, and the access will be denied. Similarly, social network sites like Facebook access might be restricted. Even the data storage outside the corporate network may not be allowed. So such kind of access restrictions are performed by the protection proxy. There are another example of firewall proxy. So proxy basically acts as a process on a firewall machine, and so in the previous example the requests from the people who are inside the corporate network trying to access resources outside are filtered or blocked, like public email, social network. Firewall is exactly opposite, where clients from outside are trying to access the corporate network or resources which are protected by firewall. So firewall is again a proxy. Essentially, client requests to the outside world, obviously from the within. So the client requests are coming from the outside world to the corporate, that's blocked. At the same time, from the corporate network to the outside world, in both the ways are intercepted by this particular process, and it decides which one to allow, which one not to allow. Depending on the security policy, it allows or stops a request. The firewall proxy essentially intercepts only the HTTP type requests, whereas the other ones like social network sites, etc., they are more sophisticated ones. As I said, the incoming requests are also intercepted, not just outgoing requests. So in the case of incoming requests, the proxy first checks for the compliance, and then the request is passed to the server. Server meaning the server which is inside the firewall. The interesting part is that both inside and outside entities are actually oblivious to the fact that there is a proxy who is controlling this access. So as long as if their requests are not denied, then the whole communication is fine, and they are not even aware of that there is a proxy. Only when the requests are denied, then they realize that there is a proxy which is controlling the access. So that's all for the proxy pattern, and with this we conclude the structural design pattern. We'll continue with other design patterns in the next class.